Welcome to Marine Tech Talk, a podcast about how Teledyne Marine's innovative technologies are enabling scientific discoveries and commercial tasks in the world's oceans and waterways. In this episode of Marine Tech Talk, we talk with Richard Jones, Vice President of Technology for Teledyne's Oil and Gas Division, and Matt Bartell, Director of Product Line Management for Oil and Gas Business Development at Teledyne. We will discuss Teledyne Marine's cutting-edge 3-channel optical feed-through system for the oil and gas industry. The 3-channel optical feed-through system is a game-changer in subsea connectivity by providing a secure and reliable method of transmitting high-speed data, power, and video signals between the subsea environment and surface equipment. The 3-channel optical feed-through system represents a significant step forward in subsea connectivity. Listen in as we explore these remarkable advancements shaping the marine tech landscape and talk tech, Teledyne Tech. Now, here's the host of Marine Tech Talk, Rhonda Moniz.
Well, welcome everyone to this episode of Teledyne Marine's Tech Talk. And we have a couple of Teledyne Marine employees on the line here on this episode of the podcast. We have Mr. Richard Jones and Matthew Bartell, and pretty psyched to chat with them. We're going to delve a little bit here today into the oil and gas division of Teledyne Marine. So let's start with you, Richard, and chat a little bit about. So we are talking about the main subject matter we have here that we're talking about is Teledyne Marine's optical and electrical feed-through systems for the oil and gas industry. And I thought maybe you could talk us through what the system is about and what its applications are, and then we'll Matthew, you can jump in, of course, anytime you like, and we'll chat with you too. I know, Richard, you handle more of the optical side, and Matthew, you handle the electrical side, right? Perfect. So, Richard, maybe you could tell us a little bit about the system and its applications.
Sure, yeah. So the optical feed-through system is a connector system that provides optical continuity through a customer's Christmas tree and tubing hanger. So you can, in the slide that is being shown right now, there's a silhouette of what's called a Christmas tree that lands on top of a tubing hanger. And these are two very large subsea components that come together to allow hydrocarbons to go from the well to the topside environment where they can be collected and distributed. And so the optical feed-through system provides that optical continuity so that fibers that are installed down in the oil well can be interrogated as sensors. And the biggest driver for the need for optics in the oil well is for a technology called distributed acoustic sensing. And with DAS, or distributed acoustic sensing, you can use them at the actual fiber optics discretely in very small increments all the way down through the well, so you can monitor things like seismic activity inside the well, the integrity of the well itself, and sand production, things like that. So there's a lot of value to the operator to get that data. And this optical feed-through system has been something that the industry has needed as a reliable solution for a long time. So now with our 3-channel system, previously there's another one on the market that has a single channel, and so there's been a lot of drive from the operators to get more than one fiber down in the oil well. And so now we have this 3-channel solution that has been successfully deployed and is working great. We're very proud of it. It's the culmination of many years of effort in Teledyne Oil and Gas, and so it's really exciting. It's a very exciting product for us.
Thanks, Richard. So you're on the optical side, and Matthew, as I mentioned, you're on the electric side. electrical side. So Matthew, you're on the electrical side.
Yeah.
What can you talk a little bit about what the electrical side is as opposed to the optical side, and what what's the difference between the two?
Sure. So for years, mostly, as Rich mentioned, the optical system is fairly new, and the optical technology down into the oil well is fairly new. The electrical one has been there for a long time, and then what it's been doing is providing communication with gauges that are down deep in the oil well. So as Rich mentioned, that Christmas tree, you see the silhouette there, what they refer to as a Christmas tree. It's kind of like the faucet on top of an oil well. It controls a lot of the aspects of it, controls the flow, controls the things that it might inject into the oil well, which condition it, condition pipelines and condition things like that. But they have electrical gauges down hole that tell them things like pressure and temperature, give them information that help them control that flow and how to adjust the faucet that's on top of the well. And the feed-through system, the electrical feed-through system, provides the communication with basically the computer that's in that Christmas tree to those gauges that are deep down in the well. And what it does is also provides a pressure barrier. So it's really in the flow, and it can actually provide a path for seepage of production fluids out of the well. So it utilizes a glass to metal seal, a high integrity, high pressure seal, which really makes it unique. But it's a very reliable seal that can take the intense pressures that are coming from the produced fluid out of the well, and provides a barrier to keep that from getting into the ocean, essentially. The optical feed-through system does the same thing. It also has that same barrier in there as well.
So it sounds like the 3-channel optical feature was added on.
It was actually developed separately. So the electrical feed-through system provided kind of a design baseline, and there's a machined prep in the Christmas tree and in the tubing hanger that accepts our connectors. And when we were developing the optical feed-through system, some of the operators were pretty adamant that they wanted the optical feed-through system to have the same prep as the electrical feed-through system, so they could choose whether they need an electrical in that particular prep or fiber optic. So it kind of the fiber optic was, came much later. I think Matt can say for sure, but I think it's probably at least 15 years that you guys have had the electrical feed-through system, right?
Yeah, I think it's actually a little bit longer than that. It's been about 20.
And obviously, it's collecting data that's really important. You need to, observe what's going on it's, I'm sure, millions of dollars worth of equipment and the assets that are down there. You need to monitor and be constantly collecting the data. So, Richard, you mentioned that this was many years in the making. Could you elaborate on that a little bit?
Sure, yeah. So we have been working on an optical feed-through system since 2018. We were funded by Equinor, which is an oil operator out of Norway, and they came to us with a desire to develop this 3-channel optical feed-through system, knowing what else was on the market, what else was available, and also knowing Teledyne's ability with fiber optics, because we have subsea connectors for fiber optics already, and they thought that it would be a good fit. So we started this in 2018 with some funding from Equinor, and managed to finally qualify the system in 2021. So it was really a 3+ year effort to go from a blank sheet of paper to a qualified TRL4 system. And that TRL4 API 17N technology readiness level means that you have fully qualified the system and all of its components, and you're ready to integrate into customer equipment. So that was a good day when we were able to claim TRL4 completion. And really, this is a culmination of about 12 man years of effort, of engineering effort within that time frame. So there's been, thousands of hours, lots of weekends and late nights to get this right. So to see it come to fruition and to actually work well in the field is very gratifying.
So Matt, on the electrical feed-through system, you guys have been at this. Obviously, the optical side of things is new. On the electrical side of things, you guys have been at this for quite some time. As you mentioned, it's like 20 years now, right? So are there any new developments on your side of things?
Yes. What's really been driving the electrical feed-through systems and development there is higher pressures, the need for higher pressures. So as the oil companies move out into deeper and deeper water, looking for larger and larger reservoirs, they're finding reservoirs that have a much higher pressure when they go to produce out of them. So we're up into the now 20,000 pounds per square inch kind of range, and that's been the latest development. So we recently qualified 2 years ago 20,000 psi electrical feed-through system that's made for a much larger tree, probably the biggest Christmas tree I think I've ever seen in person. And it's really been first installed. The first units have just been installed for the Beacon Shenandoah project, and the trees are going to be deployed into the ocean this year. So that's one of the things that's really driving it, is the higher pressure requirements for newer fields and kind of venturing out into the higher pressure range. The other thing that's doing it is reliability, just increasing the reliability of the products as much as we can, because as you can imagine, these are, once they're deployed 10,000 feet under the water, they're there. They're very, very expensive to get back up and replace, so they need to work, and they need to keep working. So simplification of the products and doing as much as we can on reliability is really what's driving the latest improvements on the electrical feed-through system.
Right, that makes sense when you're starting to go to depths that deep and putting equipment under that much pressure. Yeah, that's no it's no quick trip to get it there or get it back. So I can understand. All right,
they live in a rough environment. Yeah, both
they
of these
they
systems.
live in a rough, extreme environment, right? They got to make sure that they can last, that they're durable, and they can last.
Well, one thing that just came to mind when you're talking about the environment and the how difficult the environment is. So the tubing hanger gets installed first at the bottom of the ocean, and then it could be as long as a year later that they come back with a ship that drops the Christmas tree on top of the tubing hanger. And when I say drops, I mean it should smoothly go down and land on top of the tubing hanger, but the ship is on top of the ocean, and there could be a lot of wave action and that kind of thing. So one of the specs that we have to look at is the mating speed of the connection. So it has to withstand a half a meter per second connection speed, which is really aggressive, 20 inches per second. And so that's kind of a worst case. It probably isn't going to happen very much in the field, but it could. So when they land this Christmas tree on top of the tubing hanger and the connectors make contact, and not to downplay the electrical at all, because that's a complex system too, but you have a pretty big pin there. With the fiber optics, you have an optical fiber that has a core that's 9 microns in diameter. So that's less than the diameter of a human hair. And you have to align those two, down there at the well at whatever it is, 4,000 psi of subsea pressure on top of it, and then it has to operate at high temperature and high pressure over its lifetime. So it's a very extreme environment. It's a very difficult product to develop, and I'm just really quite proud of what we've been able to do, because it seems to be working very well in the field.
It's amazing. It's always amazing to me when you're talking about dealing with those types of environments. I mean, I've been on expeditions where I've been an ROV pilot, and just to get to that depth takes 4 hours. People don't think about it, right? They don't think about how deep it is. Just to get the ROV down to that depth, you're sitting there for like 4 hours driving it down, right? They don't think about how deep that really is.
No, it is exciting to see the optical feed-through system finally come to this development. I used to work at the same division where Rich did back in 2004 when we first started this. When I was a young engineer, I was one of the first engineers working on that. I was co-designing it with another engineer that was there that was kind of in the lead fiber optic there. And it was very difficult because of what Rich was talking about to get that to work. There was qualification testing of, they call it turbid mating, where you had to mate in a bunch of sand and silt and things you think of that would be on the bottom of the ocean, kicked up by one of those ROVs. And yeah, it didn't like it. It didn't want to pass. And it was one of the struggles we really ran into that stopped us in our tracks in the development back then. So it's exciting to see it come to fruition now.
I bet.
It works so well.
And talk about, the culmination of a lot of work and a lot of engineering, and absolutely. All right, so let's talk about the first project where you used this optical feed-through system.
So the first project, the name of it is Johan Sverdrup Phase 2, and the operator is Equinor in the North Sea. There's a total of 17 wells that required the optical feed-through system. And Equinor had planned on using the OFS in this project all the way back in 2018 when they initially funded us for the development of the connector. So we're very proud that we've met the timeline and the very rigorous design aspects and qualification tests to prove the system out. And at this point, we've delivered all of the hardware for all 17 wells. So it's a big milestone for us.
Wow, I guess so. Okay, so again, we've gone over quite a bit today with you guys, and we talk a little bit about what is next for the optical feed-through system and, what's on the horizon?
Sure, yeah. So now that we have the baseline design established and, qualified, working in the field at 10,000 PSI and 121 degrees Celsius or 250 Fahrenheit, we're looking to expand the temperature and pressure capability of that connector. So right now we're working on a 15 kPSI 2ADF, which is 138 Celsius version of the connector. So also the connection system that we have qualified as a vertical tree optical feed-through system. That higher temperature and pressure applies to a vertical as well, but we're also looking at developing a horizontal tree version of the OFS. So those are the biggest things we're working on right now.
As far as the electrical feed-through system, the next steps really are moving towards the higher reliability, because there's a lot of the talk in the Christmas tree market, or the manufacturers of the Christmas tree, our customers who are looking to create all electric Christmas trees. And what I mean by that is they're still going to use the optical feed-through system, but they were going to get rid of a lot of the hydraulic aspects of a Christmas tree and getting rid of the fluids and the tubing and a lot of the things that go with that, and make it all electrically actuated, which starts driving the need for a EFS that is ultra reliable, number one, but also that maybe performs a few more functions. And so that's really what we're looking at now is how do we make this a more reliable, more bulletproof design.
Well, listen, it's been really cool. I don't always get to talk to the oil and gas side of the business, so it was really interesting to hear from you guys. So thanks for being on this episode of Teledyne's Marine Tech Talk.
Thanks for having us.
Yeah, thanks for having me, Rhonda. It was good.
Great. Thank you, guys.
Lots of fun. All right,
Okay,
take care. Bye-bye.
Thanks for listening to the Marine Tech Talk podcast. For more information about the line of Teledyne Marine products, you can visit www.teledynemarine.com. If you have any questions or comments about this episode, you can email marinetechtalk@teledyne.com. If you like this podcast, please be sure to subscribe on Apple Podcast or wherever you are listening to the show. That way, you will never miss an episode. Thank you for listening, and we will see you again next time on Teledyne's Marine Tech Talk.